version of a very famous supply chain dynamics simulator, the beer game. It has been developed according to Jay Forrester's bullwhip effect theory, and there are various implementations of this. I think maybe the best one is really to do it in a classroom with the old-fashioned on board with the paper and cards and manual products. But this is the vibe-coded version simulation of the thing. There are a couple of videos here to see the theory behind. But just a quick introduction on the actual game. I'll just launch a game here. We need to choose some parameters. So basically, what is a time delay between the transportation? Maybe we take just the default 2 weeks. So that's how long it takes to get the stock replenished. Our objective is to run the brewery supply chain and try to minimize the total cost over the period of 50 weeks. There are some info. Holding stock is 50 cents per unit per week. Order backlog is 1 per unit per week, and then we can collaborate blindly to fulfill the demand. Okay, there are different things what we can do here, but if we start choosing the role, so let's say the easiest one. So there are retailer, wholesaler, distributor, and manufacturer. If I just take the retailer, and everybody else is being played by the computer. So we can see the customer placing the order now currently 4. And now we have stock of 12, but we have no idea what the other guys, wholesaler, distributor, manufacturer are doing. And between each of these, we have a 2-week delay. And now the question is, okay, how much we should place order for the wholesaler here as we are retailer. So let's say the current demand was 4. We have 12 in the stock, so let's just keep the same thing. And now, okay, inventory levels, everything stays on the same. We have a keeper of indicators. We just see our own numbers, but later on we can see what the other guys are doing. Okay, let's keep. This seems to be a successful strategy. Let's just go next round. Okay, now we got a demand of 8. Okay, what shall we do now? We are not able to get our stuff, so maybe it's just some random stuff, I don't know. Maybe I'll just keep ordering 4. Okay, now 8. I can maybe order a bit more. Maybe I take 12. Place an order, and now we ran out of the stock. So what shall we have to do? So now we can see what happens to the. So this is the blue line is retailer us, and what are the customer orders? So now we are placing more orders, so we don't have any stock here. And we place the order here, and okay, still on the minus side. Let's make more orders. Okay, we need to have more stuff. It seems to be having. Okay, now we got a lot of stock now. So now seems to be that we are fulfilling the demand of 8. Inbound, we have a lot of stuff coming out and place an order. Okay, so this is what happens, and then we can reveal what the other guys are doing. There is some, well, not really AI, but basically a inventory model there, and we can see what happens at each echelon here. Everybody's placing the orders according to fixed rules and nobody having any visibility. So this is what we see over here, and this is the learning of the bullwhip effect and the beer game, and you can change the role now. We just took the easiest one. I think if you play with the manufacturer, you're gonna be even more bullwhip here, demand oscillation, variability increasing along the chain. and there's some theory how actually the ordering works, how the computer players are placing the orders. Right. So yeah, it's maybe not exactly the same thing as playing with onboard game, but it's a simulation of the model. Hope you enjoyed. Thanks.